time as 6 o'clock. Let's get started. Okay, so you guys know the drill. Every Tuesday and Thursday we meet. Today is our first lesson on financial maths. So this is part of paper 1. It's not a particularly big section, but there's quite a lot to it. And again, it's important for us to start with our grade 11 work, because everything that we do in grade 11 is the basis of matric, and we know that our grade 11 work gets questioned in matric as well. So they will ask you questions on compound interest and on reducing balance depreciation. So we're going to start there. Your formulae will be given to you. So, but the ones here that will be given, so you will be given simple interest as well, but nobody's going to tell you that that's the simple interest formula. I'd be very surprised if you end up using that, but you know, stranger things have happened. Compound interest, absolutely you're going to use. Okay, so you're going to recognize that one. So A equals P1 plus IN. So A is the accumulated amount, P is the principal or initial value. N is the number of times that it's compounded, and I is our interest rate. I'm sure you guys all know that. Then it comes to depreciation, which can be linear or reducing balance. The reducing balance depreciation is really important. We always get questions on that. I haven't seen linear or straight line depreciation asked in an interview paper in a very long time, but I don't set the papers, so I can't say for sure. It's important that we know that as well. And then the other thing that we have to be aware of that gets asked as well from time to time is this over here about effective and nominal interest rates. Okay, now this formula is not on your sheet. And you'll see, I don't think it's today, but I have included a couple of questions at some stage where they ask questions about effective and nominal interest rates. So that is something that I'm going to go through with you guys as well. All right, so essentially when we are working with financial maths, we are reading the question and then we're making a decision as to which formula we think is the appropriate one to use. Remember, in financial maths, if we pick the wrong formula, we get nothing. We don't even get method marks for subbing into a correct formula. So you'll get an accuracy mark for the correct formula and then continuous accuracy marks after that. So very, very important that we do select the correct formula. I will speak more about that as we go through the questions. For now, we're just dealing with compound interest and reducing balance. And then obviously as time progresses and we move on to the more complex matric work, we will discuss whether you're supposed to be using this formula or that formula or whatever the case is. Okay, so let's have a look at our first example here. And some of these do get quite tricky. So I hope you guys are ready for a little bit of a challenge. Let's jump into the first one. So here's Craig, and he deposits 65,000 Rand into a savings account, paying 15% per annum compounded monthly. He wants to buy a car in 3 years' time. Calculate how much money will be available to him in 3 years' time if he makes a further deposit of 10,000 Rand into the account 1 year after his first deposit. That's the first question. Okay, so the best way for us to answer this is to use a timeline. Okay, so T0 represents Craig depositing the 65,000. He wants to buy the car in 3 years' time. So we've got T1, T2, T3. He deposits 65,000 Rand into the account at the beginning. And then 1 year later, okay, so a jump from here to here, he now deposits another 10,000 Rand. All right. The interest rate doesn't change from start to end. It's 15% per annum, so that's 0.15. And what do I need to do to the interest rate? Because it's compounded monthly, I have to divide it by 12. Okay, that's it, Tyler. Okay, good stuff. So whilst you're not going to get any marks for your timeline, it gives you a nice way of being able to visually represent and understand your problem. Okay, so the amount of money that's going to be available to Craig is going to be A equals, we're using compound interest. So the 65,000 Rand is going to grow from start to finish at 15% per annum compounded monthly. And then I've got to remember, whatever I divide I by, I've got to multiply N by the same thing. Okay, so it's going to be in there for 3 years. So it will be compounded 36 times in those 3 years. When I make a deposit, I'm going to add. So I'm going to add the 10,000, and that's going to be in the account earning interest at the same interest rate, but it's not going to be in the account for as long, obviously. Okay, so here, close bracket, I've got to remember to multiply N by what I divided I by, and it's going to be here for 1, 2 years. So it will be compounded twice during that time. Okay, so you guys can work that out. And share what you get. I'm getting 115,129 Rand and 86 cents.
I got the same answer.
Did you?
Yeah.
Oh, good.
Same, Chantal.
Okay, so did Chantal also get the same?
Yeah.
Okay,
I
cool.
also
And
got
Johannes.
the same number.
Thanks, Morongoa. Okay, good stuff. Okay, please, if you guys know, if I make a mistake or do something silly, please don't be quiet. Please do pipe up and point that out to me. Cool, Kanyasile. Glad you got that answer as well. So that was fairly easy. All right, now let's see what happens next to Craig. He then buys the car for the amount saved after 3 years. Okay, he drives the car for 4 years and then sells the car. Suppose that after 4 years of reducing balance depreciation, the car is worth 1/4 of its original value. Calculate the depreciation interest rate as a percentage. Ooh. Okay, so what formula do you think we need to use here, Matrix? Yes, very interesting. Thank you, Kamisile. I'm glad you agree. Depreciation, but which one, Kamisile? The reducing balance or the linear? There we go. All right, reducing, exactly, reducing balance. Yes, Chantal, so it's reducing balance. Good, so it's A equals P1 minus I to the power of N. So he buys the car for the amount saved after the 3 years. Okay, so that means that he must have spent this that I'm highlighting. Let's not highlight it in pink because it's written in pink. It's highlighted in yellow. So he's got to buy the car for this, right? That's what he buys the car for. All right. He drives it for 4 years and then sells it. Suppose that after 4 years of reducing balance, the car is worth 1/4 of its original value. What are we going to do here? So it's worth 1/4 of what it was originally. Okay, so reducing balance and P is, yes, I quite agree with you, Johannes. So if P is the 115,129,86, how do we know what the car was worth originally? because remember, we're gonna sub in here, okay? We're gonna sub into A equals P 1 minus I to the power of N. Because they've asked us to calculate the depreciation interest rate, what they want from us, Matrix, is the I. So if they want the I, it means they have to have given us the others. So we need to know N, we've got to know P, and we've got to know A. What do you guys think? How are we going to work out A? Is N equal to 4? Yes, it is. N is equal to 4, quite right. Lovely, I agree with you. So N is 4. P is 115,129,86. Isn't A what we worked out? Okay, so Chantal says, isn't A what we worked out? I'll tell you what I'm going to do. 9. How are we going to work out what A is? Where do you get Kulani? Okay, where are you getting 16,250 from? Okay, so let's just have a look at things again, right? So Craig buys the car for the amount saved after 3 years. Okay, so the amount saved after 3 years is this. He drives the car for 4 years and then sells the car. Suppose that after 4 years of reducing balance depreciation, the car is worth 1/4 of its original value. So the car is worth 1/4 of its original value. So in other words, this 115,129.86, all right, that is 1/4 of its original value. Don't we divide? What do you want to divide by 400? I think, hang on a second, I think what we need to do here, let me just double check myself. Plus, what was the interest rate? It was 15%, 0.15 over 12. 4. Lisa, what am I missing here?
Aren't we supposed to find a quarter of this amount of the 100? I mean, of the original.
Yes. So, Tanika, where did you, hang on a second. Tanika, where did you get the 28,782.47 from?
By quartering the original amount of the car, like take this amount that we got after 3 years and then divide by 1/4.
Man, how stupid can you be? Absolutely. Okay, that's out. Man. My apologies. It has been a very, very long day. I'm sorry. Matrix, absolutely, because he sells it. Okay, so the car is worth 1/4 of its original value. Quite right. So that means that we need to take A all right, is going to be the 115,129,86. And we need to divide that by 4 because it's worth a quarter of what it was originally. How silly can you be? My apologies. Okay, 115,129.86 divided by 4. There we go. Okay, so that's going to be our A, 28782,47. Okay, so because the car is worth a quarter of what it was, its now accumulated value is going to be a quarter, so we had to divide it by 4. So we've got the 28782,47 is our A equals P 115,129,86, and here 1 minus I to the power of 4. So we want to isolate our bracket. That means we've got to divide both sides by 115,129.86. You must not round off. You only round off once at the very, very end. Okay, so we are going to divide the 28782.47 by the 115,129.86. And do you get 0.25? Hopefully you do. We then need to take the 4th root of that. It's equal to 1 minus I. And then what I'm going to do is I'm going to move this minus I over to the left so that it's positive I. And I'm going to move the third over to the right-hand side. Okay, and now apparently we should be getting 0.29289 and some change. And when we times that by 100, we should get a rate of 29.3%. Okay. Sorry, I was being really silly earlier. I hope that makes sense to everybody. Okay. Can I move on? Are we all good? How are we feeling? Yes.
Ooh, I like confident.
Good.
Chantal's I like confident.
That's
I like that
lovely.
answer.
Me too. Thank you, Chantal. That's lovely. Okay, so let's have a look at another question. All right, so calculate the original price of a laptop if its depreciated value after 7 years is 3,200 Rand and the rate of depreciation was 12% per annum based on the linear depreciation method. Okay, so in this case, the formula that we've got to use is A equals P 1 minus I N, like that. So linear depreciation. So in this case, your graph is going to be a straight line that does that. Okay, not that we need to know that to answer the question. I'm just saying so. So they want us to calculate the original price of the laptop. Oh, Michelle, all you do is you just times by 100. So to go from here to here, you just times by 100. And that's why we write R as the rate. Okay. Cool beans. All right, so we want to calculate the original price of the laptop. So in terms of depreciation, the original, I suppose with appreciation as well, the original price means we need to calculate the value of P. So it depreciates to 3,200 Rand. We want to calculate P, so what it was worth originally. 1 minus 0,12 multiplied by 7. Okay, and then to get P on its own, we've got to divide both sides by the bracket. So 3200 divided by 1 minus 0,12 times 7. And you can tell me what you're getting as an answer here. Yeah. Cool, Alrina. Yes, can you see that I got the same answer? Okay, so it was originally worth 20,000 Rand. Okay, so that was really straightforward. Cool, yes, Johannes. Thanks, Hope. That's perfect. Okay, next question. So Robin invests 30,000 Rand at 16% per annum compounded quarterly for a period of 15 years. Aha, now here's this nominal and effective interest rates. Convert the nominal rate of 16% per annum compounded quarterly to the equivalent effective annual rate. So, do you guys know what the difference is between a nominal rate and an effective rate? Okay, so some say yes, others say no. All right, so those who say no, all right, a nominal rate is when the compounding period is different to the rate that has been quoted. So for example, 16% per annum compounded quarterly is nominal. But if I say 16% per annum compounded annually, then that's going to be effective. Or if I said 20% per annum compounded annually, that's effective. If I say 2% per quarter compounded quarterly, that's also effective. Okay, so it's the rate quoted has to be the same as the compounding period. Then it is an effective rate. So a nominal rate is where the percentage per whatever it is, per annum, per quarter, whatever it is, and it's being compounded differently. So now this formula, okay, you only know how to use the formula. So it's 1 plus I effective is equal to 1 plus I nom over m to the power of n. Okay, so what I must do, okay, so what I'll do here, can you see, Lee? I know it's a bit difficult to understand when someone's talking. Okay, so nominal, for example, is something like 16% per annum compounded monthly. Okay, because the rate quoted is per annum and it's compounded monthly. So if these two are different, then it's nominal. So if I say 2%, maybe let's make it a bit bigger. So 21% per annum compounded daily. We should be so lucky to get such a nice interest rate. That's a nominal rate. An effective rate would be something like 2% per quarter, compounded quarterly. Okay, so can you see that the rate quoted is the same as how often it is compounded? That's an effective rate. Okay, or if you had something like 13% per annum compounded annually. Okay, then that is an effective rate because the amount that the rate is quoted for, so per annum, is as the same as its compounding period. Okay, so that's the difference between the two. All right, so they want us to calculate the effective interest rate. So that means we need to calculate IEFF, we're going to sub in. So this is 1 plus I nom. So that's going to be our nominal rate, which is 16% compounded quarterly to the power of 4. And then that 1 is going to come over to the other side. Okay, and you're going to pop that into your calculator and you're going to work out the effective interest rate. Okay, so I don't know about you guys, but I end up with 0.16985 blah, 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 which when you then multiply by 100, you get a rate of 16.99%. Okay, is that making sense to everybody? Okay, and now they want us to use the annual effective rate to calculate the future value of the investment after 15 years. Just be careful, they do not mean future value as in the future value formula, okay? They mean A, the accumulated amount. All right, so what we're going to do now in part B, that was part A, is we're going to take how much money did he invest, was 30,000 Rand. Oopsie, 1, 2, 3. After 15 years, so to the power of 15. Okay. What do you guys get as an answer? I'm getting 315,756 Rand and 55 cents. Okay, so important that we know our nominal and effective interest rate formula in case they ask us a question about that as well. Okay, good stuff. Let's move on. How's everybody feeling? Are we all good? Good stuff. Okay, so now Pauline deposits 100,000 Rand into a 5-year savings account. 2 years later, she withdraws 20,000. Calculate the future value of her investment. And again, future value has been used in the wrong context here. They mean A. Okay, we're not using future value formula just yet because there's no installments. If the interest rate for the first 3 years is 18% per annum compounded monthly, and then it changes to 18% per annum compounded half yearly for the remaining 2 years. Good stuff. Let's see if we can do that one quick, and then we can move on. So this is different because now there is a withdrawal instead of a deposit. And as soon as you guys have got an answer, you can pop it in the chat, and then we can make sure that it's okay and we can move on. So I'm going to start doing the timeline. So if the interest rate is compounded half yearly, what should we divide the interest rate by? That's it. Well done, Kanisile, quite right. Okay, so there's our timeline. Anybody got an answer? Sorry, maybe I'm asking a bit too quickly. Okay, so as soon as you get an answer, pop it into the chat. Okay, thanks, Chantal. Okay, anybody get the same answer as Chantal? Okay, so you got the same answer, Johannes. Don't know if I made a mistake. I got a different answer. Okay, so Tisha, okay, so you got a different answer. Okay, Kulani, you got? Yeah, that's what I got, Kulani. Yeah, I got the same answer as you, Kulani. So any other answers? Anybody else get the same as Kulani? Okay, so I would have set it out like this. Sorry, I'm not trying to rush you, but this is how I would have set it out. Okay, so the 100,000 Rand goes in using compound interest, and it's going to earn interest for the first 3 years at 18% per annum compounded monthly. So here we will write 12 times 3. Okay, that money stays in the account from the beginning through to the very end. So it's going to continue to earn interest at the new interest rate, which is 0.18 over 2. And here for the last 2 years, so this is going to be 2 times 2. Then from that, we need to subtract the 20,000 Rand that was withdrawn plus its interest. Now, for 1 year, it's earning interest at the old rate. But then the interest rate changes. And now it has to lose interest at the new interest rate as well. Okay, so for the remaining 2 years, so that would be, whoopsie daisy, let me just move this over because I'm running out of space here. That would be, I was going to write 4, but it's actually, well, it is 4. It's 2 times 2. So let's just write that. Does that make sense to everyone? Yes, Hope. Okay, that's quite right. So I don't know if those of you that didn't get the 207504,74 as an answer, can you see where you've gone wrong? Okay, you didn't get the middle part. Okay, Tyler, which one? Okay, can you, yeah, sure, I'm happy to explain it again, Chantal. Okay, so Tyler, I don't know whether you mean this 2 by 2 or the last one that's 2 by 2, but I'll explain all of them again. Okay, so let me just get rid of this and I'll write it again. Okay, so the A is calculated, okay, the 100,000 Rand goes in, okay, it earns interest at an interest rate of 18% per annum, compounded monthly for the first 3 years. So that's 1 plus 0.18 over 12, and then I've got to say 12 times 3 because it's going to be compounded 36 times. Now, essentially what we do is we look at that as though that money stays in the account from the beginning to the end. All right? So it's going to then go earn interest at 18% per annum compounded half yearly. So I need to multiply that by 1 plus 0.18 over 2. Because it's going to be in the account for 2 years, that's why it's 2 times 2. Okay, Tyler? So that is what the 100,000 Rand accumulates to over 5 years. From that, we are going to subtract the 20,000 Rand that comes out, including the interest that because she's not only going to lose the 20,000, is it a he or a she in this case? I can't remember. Pauline, yes. Not only going to lose the 20,000, she's also going to lose the interest that she would have gained on that money. But because she took it out, she's now losing the interest on her 20,000 Rand as well. So the 20,000 Rand gets taken out at T2. So it loses interest at the original rate for 1 year. So from T2 to T3. So that's what this bracket is. So 1 plus 0.18 over 12 to the power of 12 times 1. But then the interest rate changes. So we have to multiply by a new bracket. So that's 1 plus 0,18 over 2. And then here it's for 2 years. So that's why we have to say 2 times 2. Okay, because it would have been compounded 4 times in that time. Does that make sense to everybody? Okay, and that's how we would have ended up with the 207, 504,74. Okay, are we all good? Are we still feeling confident and happy? Good. Pleasure, Chantal, no problem. Okay, so we can move on to the next one then. All right. So hopefully this one will challenge us a little bit more. So now we have Sean. Sean repays a loan by means of 2 payments. The first repayment of 13,000 Rand is made after 4 years. The second and final repayment amounting to 5,000 Rand is made 3 years later. The interest rate during the first 4 years is 9% per annum compounded semi-annually. For the remaining 3 years, the interest rate changes to 12% per annum compounded monthly. How much did Sean originally borrow? Okay, so what formula are we going to use? Matrix? Okay, so don't be put off by the word loan. Okay, yes, we're using compound interest, quite right. So we've got to use A equals P. When they ask us a question, when they say to us, how much did someone originally borrow? In terms of this formula, what letter are they asking us to calculate? Yeah, the P. The P. They want us to calculate the P, right? So if we make P the subject of the formula, okay, that means we've got to take A and divide it by 1 plus I to the n. Now, some of you that have, if you've done financial maths at school, you would have sometimes seen, like especially with present value, that we can use a negative exponent. So what you might see is this. Does that make sense? If not, I can explain it. Nope. Okay, so can you see there? If I had 1 over 2 x to the minus 3, all right, what you would do is you would take, or mind you, I suppose I shouldn't have made it a minus, and let's make it a plus. It doesn't need to be minus, to the power of 3. If I wanted to take that x to the power of 3 to the numerator, I can do that, can't I? So my coefficient is still going to be 1 over 2. But when the x to the power of 3 goes to the numerator, it changes its sign, doesn't it? Okay, all right. So that's just an exponent rule. Okay, it's just an exponent rule. So we can use that to our advantage in a question like this, okay? Because essentially what we are calculating is P equals A, 1 plus I to the power of negative n. Does that make sense to everybody? Oh, oopsie. Cool. Okay. So now that we know that we can do this, let's have a look at this question, all right? They want us to calculate. Oh, why is my pen not working? Come on. There we go. All right. So we're going to calculate P. So we borrowed, or not we, but he borrowed 13,000 Rand. So that's the A that he borrowed. Okay. The interest rate was, oh, hang on, you know what we should do? I think we should draw ourselves a timeline here, because the interest rate was, in the first 4 years, it was 9%. The remaining 3 years, okay, mind you, maybe an thingy isn't that necessary. Okay, so how many years is this over? It's over 7 years. So T0, T1, T2, T3, T4, T5, T6, T7. Okay, so we're trying to work backwards to this. Okay, so he pays 13,000 Rand after 4 years, and he makes 1, 2, 3, 4, and a second and final payment amounting to 5,000 Rand 3 years later. So 1, 2, 3, he pays that final 5,000. Okay, the interest rate during the first 4 years is 9% per annum, so 0.09% per annum, compounded semi-annually, so divide by 2. For the remaining 3 years, the interest rate changes to 12% per annum, compounded monthly. Okay, so the interest rate, okay, is initially 9% per annum, compounded half yearly. So now I'm going to take my negative n, which is going to be -4, and I've got to remember to times it by 2. Does that make sense to everybody? Plus, he borrowed 5,000 Rand. Okay. Now, this earned interest, okay, at this one over here, so from T4 to T7. So 1 plus 0.12 over 12. So that was for 1, 2, 3 years. So this is going to be to the -3 times 12. All right. But he would have also had to pay it back, because now we're working back the other way, if this makes sense to you. So this 5,000, it's first going to earn interest at this, and then it would have earned interest at this one as well. So 1,009. So we're literally doing the reverse of what we were doing before. Over 2 to the power of -4 times 2. Okay, so yes, essentially. Okay, but the reason why it has a negative exponent, okay, is because remember it would be in the denominator. Okay, does that make sense to everybody? So the total amount of money that he borrowed would be 5,000 Rand, which earns interest at the old rate and the new rate, and an additional 3,000 Rand that earns interest only at the new rate. We literally are doing the previous question just in reverse. And someone did share an answer. Let's see what that was. Yes, Kulani, I got the same answer as you. 11598. So 11,598 Rand and 70 cents. Cool, well done. Okay, so how does that feel? Do you have any questions? Yes, Chantal, we need to include the interest. Boutle, you're saying, why does the money he paid last year also have interest? Boutle, do you mean this over here? Is that what you're referring to?
Ma'am, I mean, like, why does the 5,000 that he paid on the 7th year also have the full interest, like the 3 times 12 and the -4 times 2?
Okay, all right. So, Boutle, what you've got to do is you've got to think of this question in reverse, right? So, if we go back up to this one over here, all right, and we look at this 100,000. Okay, so working forwards, the 100,000 first earned interest at the old rate, and then it earned interest at the new rate, didn't it? Okay, so that's why we had the 100,000 here earning interest at the original rate, and then here at the old rate. So what we are essentially doing here is we are reversing this process because we are working backwards from here to there, because we're working back to the original, aren't we? So anything that was paid back at the end, right, is going to have interest at this and as well at that, all the way back to the beginning. Okay.
Oh, okay. Thank you, ma'am. Thank you.
All right. So it's literally, as I was saying to you, it's literally the reverse of this. So if you can understand why this has 2 brackets going forwards, it makes sense why if we're working in reverse, we would have to have 2 brackets going backwards. Okay, because remember, we're trying to calculate the total amount of money that Sean originally borrowed. Okay, so if he repaid first 13,000 and then 5,000 at the end, the 5,000 at the end would have also had to accumulate interest at that beginning in those first four years. Okay.
Ma'am, I don't get the last part because like last year we never like used to add it and stuff. So I'm like a bit confused about that.
Chantal, this is a particularly difficult thing to understand. I'm just trying to think if there's another way that I can explain this to you in the amount of sort of time that we have left. The best way for you to try, okay, so Chantal, for example, do you understand here in this question why the 100,000 Rand had to be multiplied by 2 brackets?
Yes, I do.
Okay. So in other words, when we started with the 100,000, when we had to work out what we had at the end, all right, we had to take into account the 2 interest rate changes that happened in the time period from beginning to end, right? So we have to do the same thing when we work in reverse. Okay, so essentially what we're doing is the reverse of this process over here. So what he pays back at the end, all right, so starting here with this final payment of 5,000 Rand, okay, that goes all the way back to what he originally borrowed. Okay, because remember, when he makes this payment here, he's repaying this. So whilst this goes from here to here, it still goes there as well. Okay, so in order for the process to be reversed. So that's why they have to be two brackets, because the interest rate changes.
Okay, thank you, ma'am. I understand. I just like practice more.
So look at it like this. Look at it like this in the reverse. Okay, maybe this is what I can explain to you in the last few minutes. If we wanted to work forwards in this problem, all right, look at it this way. He borrows 5,000 Rand at T0. Okay, 4 years later, sorry, 1, 2, 3 years later, T1, 2, 3. So for the first 3 years, the interest rate is 0.12 over 12. For T4, T5, T6, T7, the interest rate is 0.09 over 2, all right? Then here at this time period, he borrows another 13,000. So if I said to you, how much money did he borrow in total? Can you see why you would have the 5,000 with 1 comma, so 0.12 over 12, so that would be 12 times 3. Then you would have to multiply it by 1 plus 0.09 over 2, and then here that would be 2 times 4, plus the 13,000, and then that would be 1 plus 0.09 over 2, sorry, and then that would be 2 times 4, so that would be, you would get exactly the same answer. Does that make sense to you? Buhle?
Yes, ma'am, it does. It makes sense.
Does that make sense more? Okay, sorry, not Buhle, Chantal, I beg your pardon. Okay, so we can look at it both ways. All right, are you happy with that? Makes sense now. You get exactly the same answer. Okay, because we're working backwards to try and work out how much money he borrowed in total. Okay. All right, guys, please do the poll before you go. And if you do have any questions that you want to ask, if there's anything that you didn't understand, then I'm obviously more than happy to answer you. We'll see each other again on Thursday. And then we're going to launch, this was just a bit of revision. We're going to launch straight into the matric work. Okay. All right, have a good week and we'll see you Thursday. Bye, everyone. Okay, so Hope, ma'am, why does the 13,000 not earn interest after the interest rate changed? Okay, so maybe it's easier for you to look at it like this, Hope. Okay, so look at the pink. All right, so this is the process. Imagine now he borrows 5,000 Rand, all right, and then 4 years later he borrows another 13,000. For the first 3 years, the interest rate is 0.12 divided by 12. For the remaining 3 years, the interest rate changes. Okay, so here, the interest rate doesn't change beyond 13,000 where it's borrowed. So it only needs to be multiplied by that bracket. Whereas the 5,000 stays, essentially looking at it like this, in the account for 7 years, and there are 2 interest rate changes. That's why we have to multiply by 2 brackets.